straight from previous video. Now we look at different factors. Now we are interested in finding external pressure coefficient CPE that is coming from we in the previous video we calculate the KA, KCE, KL and KP. Now we are interested in finding this CPE for windward wall, leeward wall and for roof and side wall. So now we can find this CPE value which is external pressure coefficient. Now first look at the windward wall. If I look at the picture here, the critical wind we found it on this directions. If I can show it here, in the previous video we found that 0.96 C fig is the so we are looking at in this direction, so that become windward wall and this one become leeward wall. Now for windward wall we need to look at table 5.2a on page number 33. For windward wall we can look at table 5.2a on page number 33, where we can find the external pressure coefficient CPE for windward wall. Now for windward wall we need to look at the parameter, which is the height of the building hedge, which is 25 meters. Now which should be greater than 25 or less than 25. Now the height of the building we calculated 5.5 meters. I think in our very first video where we have located the height of the building. In the first video we look at the we calculated the height of the building 5.5 meters by using that trigonometry ratio. So that is height 5.5 meters we calculated. Now so using this 5.5 meters building height, that is actually this 5 meters, and we calculated this 0.5 meters from here. So we are looking at this 0.5 meters. So the total height is 5.5 meters. That's what the building height. So that is 5.5 meters, and that falls less than 25 meters. So we are looking the table here, which is less than 25 meters, and the building is on ground, and the wind speed does not vary with the height. So it's not a high-rise building, so it's just a single-story building. So we're not looking at something that is vary with the height. So in this case, less than 25, and for building on the ground, we have two options. We have 0.8 when the wind speed varies with the height, but this is not our case. But 0.7 when the wind speed is taken when the height is not vary. So in our case, CPE is equal to 0.7. That is, so we see CPE is taken 0.7 from here for the wind speed does not vary with height. So this is the external pressure coefficient CPE for windward wall using table 5.2a. Now we can calculate the external pressure coefficient for leeward wall. So if I can show it here, the wind is coming from this end, so leeward wall is on this side. So we need to find the CPE external coefficient for leeward wall. Now we can use table 5.2b on page number 34. So if I can show it here on the page number 34, we have a external pressure coefficient for leeward wall. Now there are various parameters that we need to extract before we are going in the grade in finding the CPE. What we need to know the theta, we need to know the roof shape, we need to know the roof pitch, alpha, and we need to find a D over B. So we need to get the 4 parameters to identify which value we gonna select for external pressure coefficients. Now let's start with the wind direction, theta, and all these 4 parameters. Now for this one we are going to use figure number 5.2 parameters for rectangular enclosed buildings. Now in this scenario I can first classify the between gable roof and hip roof. Now the gable roof, that you can see it here, if you have this two slant roof, you can see this one, there are gable roof. If you have this one slant roof, so these all 1 2 3 4 5 they are classified as a gable roof, where you can see 2 slant or 1 slant of the roof, it is classified as a gable roof. Now the hip roof, if you are looking this hip roof, we have 4 slant surfaces, 4 inclined surfaces, 4 inclined surfaces. There are more than 4 inclined surfaces, 4 inclined surfaces. These 4 classify as a hip roof. So you can understand the difference between gable roof and hip roof. So you can understand the difference between the gable roof and the hip roof. So this is the first category. How do you classify the gable roof and the hip roof? Now third things, we're gonna identify between the theta, and the theta is equal to 0 degree and theta equal to 90 degree. Now please look at here in these figures. For example, here the wind is coming from this end, so the theta angle is this is the wind directions. If the wind is coming and exiting from the different height, for example, wind is entering from this point and exiting from that height, so it's a different height. In that case, theta equal to 0. For this case as well, when the wind is coming from here and exiting from that height, so you can see the slope, the exiting. So in that case, theta equal to 0. For this case, the wind is entering from this end and going down and exiting at different height. So in that case, we can consider that theta equal to 0 for that kind of roof. Now if you are taking the these examples, you can think of wind is blowing from here, so the wind is entering from this end and also exiting from the same height as is entering. So in that case, theta equal to same height, so theta equal to 90 degree. So for our case, wind is blowing from this end and it is entering at this one and exiting from this one, so it's entering from different height. In that case, we have a theta equal to 0. And so we found here from figure 5.2, we found that theta equal to also need to explain so we found that theta equal to 0. We are not considering the case, so we are in this category. Now roof shape is hip and gable, so I think in our case, our roof is in this scenario, so it's a gable roof. So that is a gable roof, and the roof pitch alpha is given. So the roof pitch is given in the questions. Alpha is equal to 7.5. That alpha is here. If I can show it here in the figure, that is a roof pitch alpha. So that alpha is given in the question, which is 7.5. So we have different value of alpha, which are 7.5. So we have less than 10. Now D on B, need to understand what is D and what is B. Now in this case, when the building has a wind coming from this end, the perpendicular to the wind is classified as B, and parallel to the wind direction is considered as a D, right? So same scenario here, perpendicular to the wind is B, parallel to the wind direction is D. So in our case, if I taking this example here, in our case, we can say that this is perpendicular. So the perpendicular one that you can say is a B. So perpendicular one is the B is this one, and the parallel is D. So D on B, D is equal to 16 meters. So that's what I put it here. D is equal to 16 meters over 24, which is 0.6, which is less than 1. So I put all the detail here. Is a gable roof, theta equal to 0, alpha equal to 7.5 given in the questions, B equal to 24 because that is perpendicular to the wind directions, and D is 16 meters, which is parallel to the wind direction. So 16 on 24 give you 0.6. That is less than. That is in this columns less than. So basically we have theta equal to 0, gable roof pitch is 7.5, less than 10, and D over B ratio is 0.6, which is less than 1. So the CPE value is minus 0.5 for leeward wall. So that is the minus 0.5 for leeward wall. And in the next video we're going to find the CPE for external coefficient for roof. Thank you.